No.
Okay. So, anyways, here we go. Stem and leaf plot. You can either write it like this, or, and there could be more numbers. If 5-1 doesn't represent 51, you would have to make a note of it, like 510. So, like with SAT scores, that's typically, or standardized scores are usually out of 100. SAT scores, I guess they can go into the thousands as well, but you would just say, hey, if that actually represents 510, then you would need to write 5/1 is equal to 510. Otherwise, people would read this in a stem leaf plot as 51. This is not read as 647. It's 64, which would be 640 in this case, and then 670. I don't mind, the book doesn't use, at least not with some of the examples, they don't use commas. I don't mind throwing a comma in there, make it distinguished, separating them out, right? If you did have something, like typically stem and leaf plots though are going to be, they're just written with a bar there, and it's like 2, 4, 6, 9, 3, 5, whatever. 2, they don't have to be in order, but it is nice when they're in order and they're written that way. So just a way to organize data when there's a bunch of data, instead of writing 24, 26, 29, you can just write 2, 4, 6, 9 representing that. Okay, if you did crest into like the hundreds, let's say, you could, and you're like all the way up to 9, and then you need to go into the hundreds, you could do something like this. That'd be like 103, 4 and 9, 109, so on and so forth. If you had that, typically you don't see that too often, but you could, and then just write the 11 there. So stem and leaf plot, way to organize data. Histogram is another name for a bar graph. Yes, mathematical name for a bar graph. So histogram, you can have horizontal ones or vertical ones, depending on what you want. Frequency table. Go to page 640. For some reason, this is confusing for some people. So let's look at page 640. I don't want to write all of this stuff down. And you don't need to write all this stuff down. You can just look at it. So what a frequency table states is how frequent, like in this case, the scores, cumulative frequency. Okay. So this is on page 640. You can look at that. So in this case, well, the frequency table would look like this and look like this. For any score between 300 and 399, there was 2 people that got that. Therefore, total 2 people so far. On the next one, from 400 to 499, you get 13 people. Therefore, the cumulative would be 13 and 2 is 15. So the cumulative frequency would be 15, and you keep going. So if there's a total of 50 people, which they were, the last one is going to have 50 for the cumulative frequency. Okay? So if 50 people took the test, the last one would be, the cumulative frequency would be 50. And this was like 700 to 799. 5 people got that, and therefore it's 50 there. Okay. Now then you have what they call the relative frequency table. And this is, again, on page 640. And this just throws down a percentage. So in the 300 to 399 range, that's the class, who scored what. And then this is the relative frequency and then relative cumulative. I'm not going to write all this. Cumulative frequency. Okay, so just to make sure we understand where these numbers come from, they don't give you 2, they give you 4%. And where did they get 4% from?
2 over 50.
Yep, if there's 50 people who took the test, 2 out of 50 is 4%. So then this is going to be 4%, right? And then when you tack on, it's not 13 people, it's 13 out of 50, which would be 26% of the people got, 400 to 499. And then what that's stating is the cumulative, you have 30% of the people so far have gotten from 300 to 499. When you get on a relative frequency table, you will max out at 100% of the people, not at the number 50. So if 30 people had taken the test, you would just figure out, 2 out of 30, whatever percentage that is. Okay. Then they have frequency polygon. They have 2 graphs there with this data that they're referring to. A frequency polygon is, they make a polygon shape with it. And so for like 300, I think they have it listed at, or I guess they have 250 to 350. And so they represent from 250 to 350, something like this, up to 350. But they represent going from here to here, and then it jumps up to that, and then goes to the peak, and then it comes down like this, and then, all the way down to whatever the last one is, 800, or there's like 750. So they're just finding this was at 2. They're taking the average, so like 300 to 399, they're just stating that's at 350. And so 2 people scored at the 350. This one, from 400 to 499, they're going to average this out at 450, and there's 13, so that would be 13. And then it continues on down, and then whatever the dots represent, like the average score, instead of, because we don't know if they got 301 or whatever, okay? So that's a frequency polygon. The cumulative frequency polygon is going to just continue to add up the scores. So the first set is up to 2, but then the next set is up to like 15, or they do it in percentages, I guess. So the next set would be like 30% like this, and it just keeps growing. The data just keeps growing up to, well, I guess it's not quite a flat line. And like this would be representative of like 100%. So that would be the cumulative frequency polygon. So again, a polygon is just a shape for that. All right. Mean. How do you find the mean?
Average.
It's the average, right? But specifically, it's actually arithmetic mean, arithmetic average, because there's geometric mean as well. So how do you find the average of something? So when they say mean, they're actually going to say x with a bar over the top. So if you see that notation, that means the mean of something. And the mean is you add up all the terms and then divide by the number of terms. They have this notation I just want to make a note of. They say this is x1 plus x2 plus x3 plus dot 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 plus x sub n, all divided by, so if there's 50 terms, right, it'd be x sub 50. They have this, what kind of notation is this? Sigma notation. You don't have to memorize the sigma notation. They say I equals 1, they say x of I, all the way up to n there. But that's just saying you're adding, right? It's just a notation. So you might see that in like statistics books, or you see it in calculus a little bit, just being comfortable with what does this represent. That just represents that you're adding up all the terms up to the nth term. So not going to put that on the test, but you find the average. Again, I don't know, when do you learn how to find the average? 4th grade? Third grade, something like that. So, median, what's the median referred to?
Oh, the middle term.
The middle term, yeah. So median, so you have mean, median, right? So if we had 34, 37, and 40, median is really easy, right? It's just the middle term, so it would be 37. Now you have to organize your data from lowest to highest. So if this was switched by chance, 40 and 37, 40 is not the median, right? So you would, have 37 and 40. Now, if we tacked on one more, like 41, what's the median now?
The average of the two.
Average of the two numbers, right? So the average of the two numbers would be 38.5. So even though the median, there is no 38.5 isn't part of your data, it would, the median can be just the average of the two numbers. Okay, now what's the last one? We have mean, median, and mode. So the mode is the number that occurs the most. If you have like this data right here, there is no mode. If there is no number that occurs more than once, there's no mode. You can have two modes, so 49, 50, 50, and 71, 71, and 100. Okay. The mode, it's numbers that occur more than once. In this case, you'd have two modes, 50 and then also 71 would be the two modes you would have. All right, mean, median, and mode, and I think that's about it.
Cool.
Yeah. These are your measures of central tendency, by the way. That's a phrase that you might hear. What are the measures of central tendency? And it's mean, median, and mode are the measures of central tendency. Okay. I don't think I printed the homework assignment sheets yet, but I will get those. But for today, if you started, you have 1 through 13 odds, 17, 21, and 25.
7, 1.
1 through 13 odd, 17, 21, and 25.
By a common D.